Hello everyone, and welcome to the Ingina Motors channel. Today, we're starting a new series about ECUs and how to connect them safely on the bench in order to read their data. As you can see, I'm currently searching for the correct pinout information for this EDC16C43 ECU. I accidentally typed EDC15 instead, but the result still appeared. However, I want to make something very clear. Searching for ECU pinout information this way is not reliable. Sometimes you may find the correct information, but other times the diagram could be wrong. Using an incorrect pinout can damage the ECU. In this particular case, the ECU belongs to me and not to a customer, so I decided to take the risk. However, I strongly advise you not to do the same. Always verify the pinout using a trusted technical source before connecting power to any ECU. Here is our ECU, originally fitted to a Citroën C4 with a 1.6-liter turbocharged direct injection engine. It has 3 sections, matching the reference image. Before installing any wire, the power supply must remain completely disconnected. We should never apply voltage while preparing or checking the pinout. According to our reference diagram, this ECU has 3 connectors, T1, T2, and T3. The connections required for this operation are located on connector T3. First, I identify connector T3 and carefully check its orientation. The letters and numbers must be read from the correct side. Looking at the connector from the opposite side could reverse the positions and cause a serious wiring error. I begin with the ground connection. According to the diagram, ground is located on connector T3, at position H4. I carefully install the ground wire while keeping the power supply switched off. Next, we prepare the 2 positive 12-volt connections, located at G1 and C3. The GoDiag harness provides 2 positive wires, labeled terminal 15 and terminal 30. Terminal 30 normally represents permanent battery voltage, while terminal 15 represents the switched ignition supply. However, our reference diagram only identifies G1 and C3 as positive 12-volt connections. It does not clearly indicate which one corresponds to terminal 15 and which one corresponds to terminal 30. During this test, I assumed that G1 was terminal 30 because its contact appeared slightly larger than the contact at C3. However, contact size is not reliable technical evidence, and it should never be used to identify the correct power connection. This is why I must repeat my earlier warning: pinout diagrams downloaded randomly from the internet may be incomplete, unclear, or incorrect. A wrong connection could damage the ECU. At the time of this test, I had not yet confirmed the correct assignment of terminal 15 and terminal 30 on this setup. We will dedicate a separate video to explaining the difference between them and how to identify them correctly. The final connection required for communication is the K line. According to our diagram, it is located on connector T3, at position B4. This line allows the diagnostic equipment to communicate with the ECU. All the required wires are now in position. We have now switched on the power supply. The GoDiag display shows 12.8 volts, with a current draw of 0.10 amps. This confirms that the ECU is receiving power and responding normally to our bench wiring. So far, everything appears correct, and we can proceed to the communication test. Now that all the connections have been checked and everything appears to be working correctly, we can begin the diagnostic test. We will now see whether the ECU responds to the DiagBox software. But first, we need to connect the DiagBox diagnostic interface. Here is the interface we will be using. The first step is to connect the DiagBox interface to the GoDiag unit through the OBD port. I carefully insert the connector and make sure it is fully seated and secure. Next, I connect the other side of the diagnostic interface to the computer using the USB cable. This connection allows the DiagBox software on the computer to communicate with the interface, which then communicates with the ECU through the GoDiag bench adapter. Before opening the software, I check the complete connection path. We are now opening DiagBox to check whether it can communicate with the ECU. Some Chinese markings are visible because this interface was purchased from China. From the vehicle list, I select the Citroën C4 Sedan with the 1.6-liter HDi engine. DiagBox now asks us to enter the vehicle identification number. Because this ECU is being tested separately on the bench, we do not have the original vehicle available to confirm its exact VIN. For this test, I enter a randomly selected VIN that follows the format of a Citroën C4. DiagBox accepts the number and allows us to continue. However, we must remember that this is only a test VIN. It may not correspond exactly to the software configuration stored inside this ECU, and this could affect how the control unit is identified later in the diagnostic process. We have now reached the diagnostic menu. I select Fault Reading so that DiagBox can begin searching for the available control units. The scanning process has now started. DiagBox is checking each control module that would normally be installed in the selected vehicle. Because we are working on the bench, the engine ECU is the only control unit connected. The BSI, ABS, airbag module, instrument panel, and the other vehicle systems are not present, so we should not expect them to respond. At this stage, we simply allow the software to complete the scan. The important point is to see whether our ECU responds through the diagnostic interface. A response would confirm that the unit is receiving power, its processor is running, and basic diagnostic communication is possible. However, it would not yet prove that every internal circuit or output stage is fully functional. The scan has now finished, and the fault code results have appeared. All the fault codes shown here are mainly related to sensors, actuators, and other control modules that are not connected during this bench test, so their presence is expected. The ECU is drawing approximately 0.10 amps, it responds to DiagBox, and it is able to report diagnostic trouble codes. These are all positive signs and suggest that the unit is operating correctly at a basic level. However, we cannot yet declare it completely functional. Further tests are required to simulate engine signals and verify its inputs and output stages, possibly using equipment such as the MST 9000+. This test also reminded us why every pinout must be verified using a reliable technical source before applying power. Thank you for watching A9 Motors. Subscribe to the channel and join us in the next video as we continue testing and learning more about automotive electronics.